In kinematics, there are two different types of graphs: velocity versus time graphs and position versus time graphs. In each graph, it has a different rule for the different thing that's being asked. The velocity is the slope in position versus time graphs. So Bob's velocity at 5 seconds is -10 centimeters per second, and Alice's velocity is 0, because there is no slope at this part of the line.
2. Yes, Alice and Bob are in the same place at 9.5 seconds because this is where the two lines intersect. This is at 9.5 seconds and 34 centimeters.
3. Yes, Alice is at rest from 4 to 6 seconds because she does not have a slope.
1. In velocity versus time graphs, the acceleration is a slope, so at 3 seconds, Zeke's acceleration is 0 and Alice's acceleration is 1.
2. Yes, they have the same velocity when they intersect.
3. To find how fast they are moving, you just look at the y value of the graph. So at 3 seconds, Zeke is moving at 4 meters per second and Alice is moving at 1 meters per second.
Sir Isaac Newton created 3 laws in 1687 that laid out the foundation of basic mechanics. The first law deals with the law of inertia. This means that an object maintains constant velocity unless acted upon by something else. An example of this is a ball in the air will eventually stop when a person catches it. Newton's second law states that acceleration of any object is in the direction of net force. From this, you can conclude that the force net equals mass times acceleration. Finally, Newton's third law deals with the law of action and reaction. This means that for every action, there is an equal and opposite reaction. An example of this is you sitting on a chair. You exert a force on the chair, and the chair exerts a force on you. A vector is a diagram that shows how fast something is moving and in what direction. To start, you'll receive a basic outline such as this one. You must figure out how to add the vectors together so they all go from tip to tail, meaning every arrow only points to one arrow. In this example, you had to make both the line of A and the line of B parallel. Once you figure that out, you need to find the sum. The mirror lines of A and B have a head-to-head connection, so to conclude, you need to have one more line meeting them. The line of C cuts through the middle and connects with both the head of A and the head of B. From this diagram, you can conclude that the sum of the line of A and the line of B equals the line of C. This sum represents the displacement.
On a sine wave, the name of the shape of a wave, the amplitude is the distance from the x-axis to the maximum. The period is the time for one repetition. The frequency is the rate of repetition. Frequency is measured in hertz. A transverse wave is a wave where the wave pattern moves at a right angle to the motion of the medium. A longitudinal wave is a wave where the wave pattern moves in the same direction as the medium. On the springs, if the longitudinal wave were moving, it would move completely horizontally, while the transverse wave would move with a section of the spring pointing down and a section pointing up. Wavelength is the distance you must move over to have a pattern repeat at a fixed moment in time. The symbol for wavelength is lambda. Wavelength is measured in centimeters. A dispersive wave occurs when the speed of a given wave depends on its frequency, while a non-dispersive wave exists when the speed of all waves is the same. Here, the bottom wave is non-dispersive because the speed is constant before and after the waves. Also, the equation for wave speed is frequency times wavelength equals velocity, which is the same as frequency divided by t, or the period. Resonance is a phenomena that occurs if you drive an oscillator at its natural frequency. For example, if a singer sings at the same natural frequency as a wine glass, the glass will vibrate until it shatters. Another example of resonance would be someone pumping their legs on a swing to swing higher, while they actually match the frequency of the swing.